I'd like to also note that what you are about to see today is the commercialization of the results of many years of research and development in our lab at UW, led by Dr. Naughton, who's also in the presentation today. Okay, with that, let's get started. Right, so in modern engineering, you always need to measure important quantities to be able to improve the performance of devices that we have around us and transportation vehicles that we use every day. Well, maybe not so much these days, but you get the point. Many of these instances involve pressure values that change with time. And these changes are very, very important to measure and study. This is what we typically refer to as unsteady pressure measurement, transient or unsteady pressure measurement. For example, the reason why we experience vibrations sitting in the plane going through a turbulent pocket in the atmosphere is those rapid changes in the aerodynamic pressure around the wing and the fuselage of the aircraft that causes those vibrations. I want to make a quick example to kind of fully define the problem that we are trying to address. In order to do that, I need to make an example here for you. I imagine we have a pipe with a periodic flow inside this pipe, and we need to capture these changes. That blue signal that you see here are those changes in the pressure inside this pipe. So we install a pressure sensor into this pipe in order to capture those changes, and these red dots are those measurements that the sensor is making. There's a problem here. The pressure inside this pipe, the flow inside this pipe is very, very hot, and it's so hot it can actually damage our pressure sensor. And we can't use it that way because it's eventually damage or melt our pressure sensor. So what we typically do is we connect a small tube to the pipe and we put the pressure at the end of that long tube. This way we can essentially reduce the temperatures that the pressure sensor is experiencing, but now we have some distortions in that pressure signal that we're trying to capture. It's okay, those distortions are so far are okay, but the temperature is still too high. So what we do is we increase the length of the tube. Now it's a little bit better, but now our pressure measurements are becoming very, very distorted. But still the temperature is too high. So by the time we have reached a point that we can put the pressure sensor in a location that it's safe, our measurements are completely gone, right? What we were interested is very, very distorted, and we can't use that anymore because it's not representing that blue signal, which was the true pressure variation inside the pipe. To give you a perspective, this can be a gas turbine engine. It can be a turbofan engine of a commercial airplane. It's essentially the same concept. And we don't want to hop on a plane that has these kind of pressure measurement and these kind of pressure capturing in that pressure, for example, in the gas chamber of that turbofan engine. So this is the problem that we are trying to answer, how to accurately measure the unsteady pressure if the pressure sensor is very far from the measurement point. And it's very, very common in the industry, as we'll further discuss that later in this presentation. So what's our solution? We have developed a system through many, many years of research that has some signal processing algorithms, very advanced signal processing algorithms with some precision, state-of-the-art precision electronics and data acquisition hardware that takes those distorted measurements and predicts what those actual measurements inside the pipe, for example, are, right? This is our solution. So Turn out there is a lot of value for this methodology, for the system that we have developed. It essentially eliminates instances of sensor failure. It increases the quality of the measurements and provides flexibility in measurement system design, because now you don't have to, for example, jam like 500 pressure sensors in a small area. You have those tubes, so you can put the pressure sensors further away from where you're actually making the measurements. And eventually it reduces the testing time, which means a reduction in the cost, and a lot of cost saving. Where we are at in terms of this technology, the development of this technology. In 2016, we actually entered the commercialization phase of this technology. We proved the concept for a long time. We had our first working demonstration in our wind tunnel lab. And that's what essentially helped us to enter the Fisher innovation. Since then, with the help of the Fisher, we were able to build our first working prototype in 2017. And then that led to more demonstration, to more interested parties, which brought more funding and enabled us to build our first functional prototype in 2019 that we are using to show it to a lot of different customers. Right now, we are working on the first commercial prototype for our lab system. In terms of market validation and who we're talking to and different customers, the first, I would say, the first mechanism that we used was presenting at technical conferences. Many people came to us and asked us, hey, where can we buy one of these technologies? And then, well, we have to build it for you. After that, we started a strategic partnership with TE Connectivity, that actually is a worldwide leader in pressure sensor technology, and they see our technology as an enabler for their pressure sensors and pressure scanners. They have seen a lot of demand from different industries that they need something to reconstruct those measurements in application, and they have to install the pressure sensors remotely. And we have also done a lot of personal and interviews with our potential customers. We have demonstrated our prototypes to them, and they are very interested. I actually have some testimonials here, which I put in the business plan that the judges should have, from different customers in aerospace industry, from government sector, industry sector, educational sectors, and these guys all have seen our technology, and they see it as a game changer for a lot of applications that they really don't have a solution to overcome some of those distortions that they see in their measurements. So how many of these customers do we actually have? So based on our research, we have seen a lot of demand in aerospace engineering, in ground transportation, in sports, wind engineering, and wind energy. And typically from all these industries, we see three different types of applications in their wind tunnel testing or field testing, or for the aerospace, for example, we have a gas turbine engine, which is a whole other story. Right now, we are focused on three segments: wind tunnel testing and gas turbine engine testing for aerospace engineering, and then field testing for renewable energies and wind energy. We have narrowed down our target customers within these three segments even a little bit further, to really work with people that we have done our research on. We understand exactly what their needs are, and they have seen our system, and they understand what we can provide. And this is essentially that first available market that we have identified based on these narrow target markets. So what is it that we are offering? We obviously have some hardware components, 3 different products for 3 different applications that I've mentioned: lab system, a field system, and high temperature system for gas turbine engine testing. We sell the hardware. Our data processing software is based on subscription, and we also provide services based on customer needs. And we are trying very hard in order to protect the intellectual property of all different components of our system. We have 3 patent applications in process, working on the applications, and our software is copyrighted. In terms of numbers, we have three different systems, and these are the numbers of products that we predict we can sell within the next 5 years. That will result in about $7.6 million in sales revenue. In the plot on the bottom left, I have also the gross income and earnings, and these numbers also have the R&D money that we're also anticipating to bring in, for example, like SBIRs. And for more details, please look at the business plan. I have narrowed down all the assumptions that we have made in order to come up with these numbers. Where we are at right now, again, like we started the commercialization in 2016, we are in a good place in terms of our field testing system. We have some customers, we are talking with some customers, and they are interested. We think only with some small modifications we can develop the system for them. And right now we're focused on our lab system, and that's where this Elbogen essentially grant will come to help us. One important point that we are very proud of is we are a Wyoming startup. We spun out of University of Wyoming. We are creating high-tech jobs here, and we are an employee-owned company, and we plan to stay in Wyoming and use University of Wyoming resources, and we have done some contracts with them. With that, I'll just leave the summary slides up, and I'm happy to ask any questions you may have.
Thank you, Pourya. Appreciate the presentation. We'll give our silent language round of applause. Excellent job. And what I may actually do, it's hard to see our judges when your screen is shared. So for your own sake of being able to kind of see them ask the question, I might ask you to stop the screen share. And then if you need to throw a slide back up as you're answering questions, feel free to do so.
Sure.
So I'm going to go back to our judges mode. So judges, I now have you all on the same page so I can see you at the same time. So I apologize, Spencer, for not getting to you before we ran out of time. So Spencer, if you have a question, you'll get priority. But I did see Stephen already raise his hand. So we'll go Stephen, and then Spencer, you'll be next if you have a question. So Stephen, go ahead and start.
Thank you. Oh, good work. Lots of work behind that, I know, and a good presentation. So thank you. Kind of a small geeky question to help me get the system straight. Can you talk about what is the column between the source of pressure variation and the transducer itself? There's a column of some kind. What is that material, or what is it?
Right now, you mean, for example, the media that you're doing that measurements?
No, the tubing, and the...
It's essentially, for example, if you are measuring combustion pressure, it's just the gas. Is the gas that is the result of the combustion that is between the pressure surface and the transducer. It's filled with the same medium that's inside that pipe that you're doing the measurements, air essentially.
Gotcha. Okay, thank you.
Sure.
Okay, Spencer, go ahead with your question.
Yeah, I wanted to learn more about what you're pursuing for intellectual property. Obviously, the software is the most critical, I would think, portion of the IP, because that's what is taking that very distorted signal and actually making it usable. If you want to expand on that and any other aspects that pertain to the IP.
Sure. The theory behind everything that we are doing was essentially proved in 1960s, or even probably before that. what we have done is that we have used those theories in order to come up with practical algorithms and essentially practical algorithms that can enable using all that theory. These algorithms, we can't really patent them, right? So we're trying to keep a lot of that as trade secrets. But in order to ultimately enable using those algorithms and actually apply it to applications, there is a lot of hardware innovation that we have done to enable using that algorithm. What we are focusing on is to patent those hardware solutions that we have added to enable these theories and these algorithms to be effectively used in order to reconstruct those signals with the least amount of uncertainty.
So just as a quick follow-up, in a sense, like the sensing lines or other hardware components to get the sample to the device, is that part of the patent materials or IP that you're looking at?
In a way, yes. So the main important thing that we have is because application to application, there is a lot of changes. There's always a lot of unknowns about the system that we are trying to reconstruct its pressure measurements. We have developed an in situ system characterization hardware, a handheld device that any user can use to fully characterize the physics behind that tubing line that they're trying to reconstruct the pressure signal that are traveling through that. And that's our hardware, essentially. That's the biggest part of the hardware that we have. In addition to that, we have some software and additional algorithms that we're combining with our hardware to also patent a methodology, essentially, that's combined with some hardware and some algorithms and codes. So we have some hardware design, essentially, patent and methodology patent coming up.
Thank you, Spencer. Other judges have a question as well. Walden, go ahead, and then Susan will go to you next.
So is all the IP and all this stuff in one company, or would you consider it something where you have basically the computer side of things and the algorithms and all the software tracking and all that stuff in one side, and then you have the hardware and the actual materials and everything else as a separate, like, standalone revenue channel? Because technically I think there's multiple business avenues here for revenue purposes that you could explore.
That's true. For example, if you noticed the Arnold Engineering Development Complex, when we talked with them, they were, as you said, they were very interested in our software, in our methodology, and pieces of our hardware. They're telling us, hey, we have the most advanced data acquisition hardware that is out there. We don't need your data acquisition hardware. What we need from you is your software plus that handheld device that we showed them. So yes, you're right. And we are kind of trying to develop this commercial prototype system that is as flexible as possible, so that if the customer says that, hey, we don't need that data acquisition hardware, we need this piece and that piece, we can provide that to them. Right,
because when it comes to pressure in the systems, like the industries that you were looking at, anywhere from high performance engines to jet planes to whatever, like being able to like fine tune based on that analytics, based on pressure, between that all the way to running oil and gas compressors or whatever pipeline wise. Like, I see there's huge applications in those industries where I think your market cap's actually a lot broader than you think. But I think what you're going to end up doing is probably separating out those two different business models. But which leads me to my last question here. But when it comes to the IP side, like, does anybody else own percentage points of it? Is it like is there any equity tied back to the University of Wyoming or the grants that you've already received? Do people own any parts of the licensing?
I'll just start, but Dr. Naughton, please feel free to correct me. Right now, what we are trying, all the IP, all the owners of the company, all of them are people who have been involved in developing the IP. So everyone who has been involved in developing the IP is an owner in the company. In terms of filing our patents, we actually, as of now, we are planning to use university, because most of the stuff that we have developed are part of a research that we have done at Dr. Naughton's lab. And we feel that it's actually a more protective way of applying for patents. Dr. Naughton, is there anything else?
No, I think that's accurate. I think, we want to give some credit to the fact that the work was done at the university and those rates will be negotiated. That has not been done yet. But at the same point, I think Pourya's point is all the IP of all the pieces here are members of the company. So that really helps.
Okay, Susan, do you want to ask your question?
Yeah, leveraging off of Walden's question, I guess, on the prototype that's will be developed. Explain how you're going to, or what that prototype will look like. Have you partnered with somebody that you could get more or be more confident that there would be leverage off that prototype that would be very quick to launch you into a specific category, or how do you get that done?
Yes, we have a very good, we've built a good engineering team. We actually, to be more clear, we have about six engineers who are working full-time and part-time in Resono. We believe that we can build that prototype ourselves. What we have developed so far actually has a lot of, it looks like a good system. It's not like a laboratory package yet, but we have good ideas and we think we can deliver that. What we're mostly focused on is our software, like developing our software and getting that into a much better shape than it is right now. T actually has brought up the discussion of licensing some pieces of our hardware, for example, that handheld device that we're building, as something that they can help us to build it in better quality, and they want to make sure it'll communicate also with their systems. Right now, we haven't continued that discussion with them yet. We are kind of focused on building at least a first commercial prototype that we think has all those different features that we feel that must be in our commercial prototype, and that would put us also in a better position in terms of negotiations, so that when we go to talk to these people that are going to license different pieces of this hardware, we feel more confident.
Susan, can I add that we have partners, kind of end user partners that we're kind of working with on each of these prototypes. So the wind energy application was the Department of Energy. For our combustion related system, it's Arnold Engineering Development Center. And for the lab system, it's the US Air Force Labs. So we have specific partners that are giving us feedback on the systems as we develop them.
Okay.
Great. I think we probably have time for one more question. If a judge has a question, or if an audience member has a question, you can send it to the chat window that says send questions here, and we'll try to carry it forward. Judges, any additional follow-up questions? Spencer, go ahead.
So one thing that we like as a theme of this whole competition is trying to bring tech and more jobs to the state. The state's obviously going through a big transformation. Can you talk about how your company and maybe the number of jobs this could potentially bring to Laramie or the state in general?
Yeah, absolutely. So right now, as I mentioned, we have about one full-time employee, myself, and we have 5 part-time employees. All of these 5 people, part-time, they're all somehow associated with University of Wyoming. 3 of them are former grad students. 2 of our group, 2 of them are former grad students. We are right now we have about $1.3 million of grant under review, grant applications that are under review.
I touched the mouse
And
it says
Sorry, we'll get that muted real quick.
Oh, okay.
Sorry about that. It's not you.
No worries.
Go
and
ahead.
what we're trying to do is, so these fundings, that if they go through, we have actually planned to bring back these Wyoming natives to state of highly educated engineers back to Wyoming to become full-time in the company. So far, we have worked with interns from both LCCC and University of Wyoming, and that's we feel essentially that as a very important part of our business development. We have access to highly educated graduates here at the university. We have, through STTRs, essentially, we have also partnered with the university in a lot of these different R&D projects, because working with the university, being here, enables us to have access to very state-of-the-art labs and state-of-the-art machine shops. So we feel that being in Wyoming and being in Laramie specifically has a lot of advantages for us, not just from workforce standpoint, but also access to high-tech technology through university, through these subcontracts that we have with the university.
Spencer, just to add to that a little bit, I envision with some of our models of how it would grow about 10 employees within the next 2 to 3 years. And then the real unknown is the growth of the service side of the business. If we get a lot of people wanting us to build custom systems or custom models or characterize systems, or all of a sudden another area booms, that could go very quickly much larger, because that's very engineering intensive. And then as we expand into other areas, the markets could potentially be much larger, as Walden suggested. So.
Great. I'm going to step in and we're going to call that a wrap on all of our questions. Thank you so much, Pourya and Dr. Naughton, for being here today. We'll do our sign language round of applause / jazz hands. You can make it whatever you want it to be. Thank you for all the hard work you put into your presentation and your business plan. And we will ask you to sign off now and come back for the determination of who advances at 4:30 this afternoon. So thank you again, and we will see you later this afternoon.
Thank you for the opportunity.
Yes, excellent.